All right, let's talk about one of the biggest headaches when you're building AI agents: memory. How do you get an AI to actually remember what's important in a conversation without it just drowning in all the noise? Today, we're going to dive into a really cool way to turn all that messy conversational chatter into solid, usable facts. So let me just ask you this straight up. Is your AI's memory just a big, messy pile of chatter? If you've built any kind of agent, you know exactly what I'm talking about. Every little hi, every typo, every time you correct it, it all just gets dumped into this unstructured log that's almost impossible to use for any kind of long-term memory. And this really gets to the heart of the problem. On one side, you have chatter. It's noisy, it's temporary, it's a total mess. Kind of like a desk that's just covered in sticky notes and random scraps of paper. But on the other side, you have facts. These are compact, they're durable, and they're structured, like a beautifully organized file cabinet. Our goal is to build a system that automatically turns that messy desk into that clean file cabinet. So how do we actually do it? Well, the answer is something called the compaction principle. It's a really simple but powerful architecture that's designed to separate that temporary mess from the permanent, valuable memories. Okay, check this out. Here's the core of the whole system, and it's called the two files pattern. First, you've got a raw log.json. Think of this as your messy scratch pad. It captures absolutely everything, but the key is it's temporary. Then you have state.json. Now this is the good stuff. This is your durable, long-term memory, all kept in a nice, compact, structured format. And this separation is so critical because it makes finding and fixing bugs way, way easier. But for that state.json file to be useful, it needs a blueprint, right? And that's where the output schema comes in. It's just a predefined structure, a consistent JSON format that tells the AI exactly how to organize the information it's saving. By setting up categories like facts or user preferences or maybe open questions, you make sure the AI's memory is always predictable and actually usable. So, we've got the principle down. Now let's get into the practice. This is the simple four-step workflow that actually turns those raw, messy logs into a clean, compacted state. And it works just like this. Step 1, collect. You just grab the last few chunks of conversation from your raw log. Step 2, merge. You hand this new info to an LLM and ask it to merge everything into your existing state, making sure it follows your schema. Step 3 is absolutely vital. Validate. You have to strictly check the LLM's output to make sure it's perfect JSON. And then finally, step 4, save. You just overwrite the old state file with the new one. It's simple, it's repeatable, and it really works. Now, this all sounds great in theory, but, in the real world, there are always traps. We need to talk about navigating the reliability landmines that can totally blow up this workflow. Let's look at the most common ones you're going to face. Here are the top 3 things that are definitely going to trip you up. First, for some reason, LLMs love to wrap their perfectly good JSON output in markdown code fences. Second, they might just get the format wrong, giving you a string instead of a number, or just forgetting a key entirely. And third, because this process isn't instant, your app might look like it's totally frozen to the user. Let's just zoom in on that first landmine for a second because it's such a classic. You ask for JSON, you get JSON, but it's inside a markdown block. And if you try to parse that directly, your code is going to crash every single time. The solution is simple, but it's essential. You have to programmatically strip those fences before you even try to parse the JSON. And this brings us to what is probably the most critical rule of this entire process. You can never, ever trust the LLM's output blindly. You have to validate it. Every time. Check that every key you need is there. Check that every value is the right data type. One single piece of bad data in your state.json file can corrupt the AI's entire memory. So, yeah, trust, but verify. Finally, let's talk a little bit about user experience. This whole compaction process, it's not instantaneous. So to keep your user from thinking the app just crashed, you gotta give them a simple heads up. A little UI cue, like a spinner or a message that says, compacting memory, makes a world of difference. It manages their expectations, and it turns what could be confusion into a sign that something smart is happening in the background. Okay, so we've covered the what, the how, and the what to watch out for. So now, it's your turn to take this pattern and put it into practice. Go build a reliable memory system for your own projects. And here's a great exercise to get you started. First, think about privacy. Add a do not store list to automatically redact sensitive information before it even hits your raw log. Then have a conversation that's long enough to trigger the compaction process, and then go in and personally check to make sure absolutely no sensitive data made it into that final state JSON file.
If you remember nothing else from this, remember this 3-word mantra: log everything, messily and temporarily, compact it into a clean, structured state, and then verify relentlessly to make sure it's reliable and safe. Log, compact, verify.
So I'll leave you with a final thought here. This entire process is really all about distillation. It's about finding the signal in all the noise. So if you had to start from scratch and your AI could only remember 3 essential things from any given conversation, what would they be? Something to think about. Thanks for watching.